All right, let's jump right into a really wild question today. A cosmic what-if that has a surprisingly down-to-earth answer. What if our moon just, poof, turned into a black hole?
I mean, really picture it. You look up at the sky one night, and the moon is just gone. In its place, a black hole. But here's the key, the really important part. It has the exact same mass. Not an ounce more, not an ounce less. So, what happens? What happens to us down here on Earth? Well, let me tell you, the answer is probably not what you're expecting. Usually when we think black hole, our minds go straight to something like this, right? This cosmic monster, a gravitational beast that just devours stars for breakfast and bends space-time like it's nothing. It's an awesome, terrifying image. And the idea of having one right next door? Yeah, that's a little unsettling, to say the least.
So to figure out if we should actually be worried, we have to dig in and treat this like a real scientific question. And like any good thought experiment, we've got to start with the basics.
Okay, so to really get what would happen, we need to forget the Hollywood movie version of a black hole. It's not some cosmic vacuum cleaner just sucking everything up. It's all about one simple but super powerful idea, the concept of escape.
All right, let's break this down. The basic physics here are actually pretty simple, and once you get it, the whole puzzle just clicks into place.
So anything that has mass also has gravity. And because of that gravity, there's a certain speed you need to hit to get away from it. We call that escape velocity. Think about it. For a rocket to leave Earth, it has to be going incredibly fast to break free from Earth's pull. Well, a black hole is just what happens when you crush an object down so much, make it so dense that its gravity becomes unbelievably strong. So strong that its escape velocity is faster than light itself, the universe's ultimate speed limit.
Just look at these numbers. To get off Earth, you need to be hitting over 11 kilometers every single second. That's just mind-bogglingly fast. But for a black hole, that's practically standing still. You'd have to go faster than 300,000 kilometers per second, the speed of light. And since we know that's impossible, well, nothing gets out. Period. Not even light.
Okay, so this is the big one. We're taking the entire moon, all 70 quintillion kilograms of rock and dust, and we're crushing it down, squeezing it, until it's so dense that its escape velocity is the speed of light. So how big would it be? What are we left with? The size of a football stadium? A car? What do you think?
Not even close. We're talking about 0.1 millimeters.
Yeah, you heard that right. The entire mass of our moon, crushed down into something smaller than a grain of sand. Just let that sink in for a second. Every single mountain, every single crater, all of it, packed into a space so tiny you couldn't even see it. The density is just off the charts.
So now we have a totally different picture, right? We're not dealing with some giant gaping maw in space. We're dealing with a microscopic dot that has the mass of the entire moon. And believe me, that changes everything. Okay, so let's circle back to our original question. What would a black hole the size of a sand grain actually do to the Earth? What happens to us now that this invisible, super dense thing is orbiting us?
Well, after all this buildup about unimaginable density and the speed of light, the answer is, well, it's a bit of an anticlimax, honestly.
Pretty much nothing. Yep. For us, down here on the surface of Earth, almost nothing would change. And the reason is actually really simple. See, when it comes to gravity, once you're far enough away, the universe only cares about two things: how much mass something has and how far away it is. Its size doesn't matter at all.
So, what does that actually mean for everyday life? Well, the tides, they'd keep rolling in and out exactly the same. The Earth's orbit, its familiar wobble, all the same. The only things we'd really notice would be that our nights would get super dark without any moonlight. And, oh yeah, we'd lose our big rocky shield that protects us from some asteroids. But that's it. From nearly 400,000 kilometers away, the pull from a moon-sized rock and a sand grain-sized black hole with the same mass is identical. But that's just the story from way back here on Earth. What if we hopped in a spaceship and went to go check out our new neighbor up close? Well, that's where things get very, very different. You know how gravity gets stronger the closer you get, right? Well, with the old moon, if you flew toward it, you just land on the surface. End of story. But with our tiny black hole, there's no surface to stop you. You could get incredibly close to all that mass. And as you got closer, the gravity pulling on your feet would be so much stronger than the gravity pulling on your head that you'd literally be stretched apart like spaghetti. It's a real term, I promise. Spaghettification.
So having this thing in our backyard is kind of a double-edged sword. The bad news? It's super dangerous. A stray asteroid could get whipped around it and slung directly at Earth. But the good news? It's also an amazing opportunity. We could use its intense gravity to slingshot our spaceships out to Mars or Jupiter way faster than we can now. And we might even be able to use it for power.
Here's how that would work. If we could carefully guide something into it, like an asteroid or some space junk, it wouldn't just disappear. As it gets pulled in, it would spiral around and form this incredibly hot, glowing ring of matter called an accretion disk. The friction in that disk would release a staggering amount of energy, mostly light and heat. If we were smart enough to build something that could capture that energy, we'd have a power source that could last for, well, practically forever.
Okay, so let's put aside all the sci-fi stuff for a second and think about the past. Because this whole scenario brings up a really deep and fascinating question about us, about how we figured out how the world works in the first place.
Just imagine for a second. Imagine humanity grew up without a moon. No big, bright circle in the night sky. Just this tiny, invisible point of gravity. Something we could never, ever see, but something we could absolutely feel every single day.
I mean, think about it. The tides would have been pure magic for thousands of years. How would you explain them? Isaac Newton's whole theory of gravity might never have happened because he couldn't see the thing pulling on the Earth. All of our myths, our stories, our ancient calendars, so much of human culture is built around that big, beautiful, visible object in the sky.
It's a really mind-bending idea, isn't it? It just goes to show how much of our science, our entire understanding of reality, has depended on us being able to literally see what we're studying. It makes you wonder, doesn't it? What else is out there? What other huge, fundamental forces are shaping our universe that we just can't see, yet?